There is a terrifying possibility that human consciousness was never fully human to begin with. Not metaphorically, not spiritually, but literally. And according to some of the most prominent theoretical physicists of the modern era, the ultimate clue appeared inside the mind of a man so astonishingly intelligent that even Nobel laureates were intimidated by his cognitive speed. His name was John von Neumann.
Decades after von Neumann's death, mathematical physicist Sir Roger Penrose began to suspect that this extraordinary brain was operating in a manner that no classical machine, and perhaps no ordinary biological brain, should be capable of achieving. Something mathematically non-computable.
Because the deeper physicists looked into the nature of human intelligence, the more one disturbing question refused to disappear. What if the human mind is not merely computing physical reality, but directly interacting with a fundamental layer of the universe that exists beyond computation? To understand why Penrose became obsessed with von Neumann's mind, one must first examine who this individual truly was. To characterize him merely as a genius is a profound understatement. As a child, von Neumann could divide 8-digit numbers in his head and memorize entire columns of a telephone directory on a single reading, retaining them with perfect recall years later. His peers described his conversational patterns as feeling almost mechanical, yet not mechanical in the sense of a simple machine, but rather like an intelligence operating several dimensions above everyone else. He went on to shape the modern world, pioneering game theory, the mathematical architecture of modern electronic computers, nuclear strategy, and the theoretical foundations of artificial intelligence decades before the physical technology existed. Yet, the more advanced von Neumann's ideas became, the more unsettling the implications felt. He treated the universe itself as an informational process, a vast, cold system built entirely on pure logic. But if the universe behaves like computation, then what exactly is consciousness? For decades, classical science offered a comforting reductionist answer. The brain is simply a biological computer. Thoughts are calculations, emotions are electrochemical patterns, and memory is passive storage. The mystery was considered solved before it was ever truly understood. But Roger Penrose was deeply uncomfortable with this mechanical dogma. The deeper he analyzed mathematics, the less he believed that conscious understanding could ever be reduced to computation alone. In the 1930s, this suspicion found its ultimate mathematical weapon when Kurt Gödel published his incompleteness theorems. Gödel proved that within any consistent logical system, powerful enough to describe basic arithmetic, there will always be mathematical truths that the system itself can never prove, using its own rules. This realization haunted Penrose. If a computational machine is strictly bound to follow predefined rules, yet a human mathematician can instantly perceive the truth of a statement that lies beyond those rules, then the human mind cannot be algorithmic. Therefore, consciousness must involve something fundamentally non-computational. Penrose began promoting this radical idea, but the scientific establishment dismissed it. The world had already accepted a simpler, safer belief. The brain is a machine, and eventually, computers will become conscious too. Yet this computational dogma faces a glaring, real-time limitation today. Modern artificial intelligence can calculate faster and process more data than any human mind. But behind this flawless performance lies an absolute void. A machine can simulate understanding perfectly, while possessing zero inner experience. It can describe pain, but cannot suffer. It can analyze love, but cannot feel attachment. This suggests that computational power is not the missing ingredient for consciousness. Computation itself is the wrong physical category.
But if consciousness is not computation, where does it originate? This question dragged Penrose into the most volatile layer of physical reality, where reality remains unfinished until a measurement occurs. While most physicists avoided connecting quantum physics to the mind, Penrose noticed that quantum systems resist classical computation, performing processes no algorithm can fully capture. Quantum mechanics. This is a world where particles exist in multiple states at once, where observation changes physical outcomes. And what if the brain is not merely processing classical information, but interacting directly with this fundamental quantum structure of reality? Suddenly, von Neumann's historical legacy took an even stranger turn. Decades earlier, von Neumann had formalized the mathematical foundations of quantum mechanics, confronting the infamous measurement problem. In quantum theory, particles exist as probabilities until observation collapses them into a definite state. But what constitutes an observation? A physical detector is also made of quantum particles, meaning it too must enter a state of superposition. This creates the von Neumann chain, an infinite regression of physical devices, none of which can collapse themselves. Von Neumann's mathematics quietly pointed to an unsettling implication. The physical chain can only end when the measurement is read by a conscious observer. Consciousness does not merely observe reality, it completes the physical loop that brings reality into existence. If this is true, then intelligence does not begin in the brain. The brain may only be accessing it. For over a century, science treated consciousness like steam rising from classical machinery. But Penrose and anesthesiologist Stuart Hameroff proposed a radical alternative called orchestrated objective reduction, or Orch-OR. They identified microscopic structures inside neurons called microtubules, while biologists dismiss them as simple cellular scaffolding. Penrose and Hameroff argued that these microtubule lattices shield quantum coherent states, allowing the brain to act as a quantum receiver. Consciousness, like gravity, is a fundamental feature of the universe, discovered rather than invented by physical matter. This leads back to the chilling paradox of John von Neumann. What if minds, like his, are not computing reality faster, but are instead biological antennas tuned more deeply into this fundamental quantum layer? Throughout history, certain individuals have appeared almost impossibly ahead of their time, producing insights that seem less invented than discovered. If this possibility is real, then the human mind is not confined to the human skull. It reaches into the very fabric of space-time. And if human consciousness truly reaches beneath physical reality, what else might already be reaching back? This channel wants to find the answers to these questions, so stay tuned.